Welcome to this Maths Made Easy video on selecting a distribution. To start with, let's take a look at the conditions that are required for a binomial distribution. And the first condition that we require here is that the data is discrete. So the data is discrete. So nice and simple, that gives us our first condition there. The next condition here is that there's a fixed number of trials, which in the case of a binomial distribution we denote as n, and we only have two possible outcomes, success or failure. So let's write this down in full here. So there's a fixed number of trials here, and again, in a binomial distribution, we often just denote this as n. This is one of our parameters here for a binomial distribution, and we only have two possible outcomes. So we've only two possible outcomes here. And remember, those two possible outcomes for the case of a binomial distribution is success or failure. Okay, so that's our second condition. And finally, we move on to our last condition here for a binomial distribution. And here, the success probability, again, for the case of a binomial distribution, which we denote as P here, is constant, and every trial is independent of each other. So, let's write this down again in full here. Success probability which we denote as P here, again, this is our second parameter in the case of a binomial distribution, is constant. And every trial is independent of each other. Okay. And that gives us our final condition there. Okay, so to summarize again, the data must be discrete. There's a fixed number of trials, which we denote as n there, with only two possible outcomes, which are success and failure. And finally, the success probability P is constant, and every trial is independent of each other there. And that gives us the conditions for a binomial distribution. Moving on now to the conditions required for a normal distribution. And again, we have three conditions here, so let's note all of these conditions down. So the first condition here is that the data must be continuous. So the data is simply continuous. Okay, so that's our first condition there for a normal distribution. Our second condition here is that the data is symmetrically distributed, or we'd say very close to being symmetrically distributed. Okay, and we also note that there's a peak at the mean. So here, the data is symmetrically distributed. So the data is symmetrically distributed. Or we'd say very close to. And remember, there will be a peak at the mean here. Okay, and our final condition here is that the data tails off as you move away from the mean. So the data tails off as we move further and further away from the mean. So the data tails off as you move away from the mean. Okay. We can also add an extra point on here that almost all of the data should fall within 3 lots of the standard deviation of the mean here. Okay, so almost all of the data should fall within 3 lots. So falls within, I'll denote this as 3 sigma here. So 3 lots of the standard deviation of the mean. Okay. And that's our final condition there for a normal distribution. So here, to summarise, the data must be continuous, the data is symmetrically distributed, or very close to, with a peak at the mean, and the data tails off as you move away from the mean, and almost all of the data falls within 3 standard deviations of the mean there. Okay, so that concludes this Maths Made Easy video on selecting a distribution.